Hello, everyone. I'm Kyle Davis.
I'm Brandon Kennedy.
I'm Alec.
And our fourth partner is Nadim Ibrahim. He is a student at Azraeli College in Jerusalem. And this is our presentation on industrial wastewater treatment and applications. So just a little bit of background. We, like last month, we went and visited Jerusalem in Israel, and we attended a couple labs at Azraeli College about wastewater treatment. So we were tasked with collecting water from an industrial plant. The plant name that we collected the water from was Extol, and they do metal finishing. And this wastewater from them contained high amounts of metal contaminants, mainly due to their production of aluminum and copper alloys. We needed to reintroduce the treated water into a stream or river. So the first lab was water analysis, just kind of testing the wastewater that we had. And we tested for the following categories of parameters. All wastewater contains, at least one of the different parameters. And so these kind of categories were physical, chemical, and then under chemical, you have organic or inorganic contaminants, and then microbial. So a couple of key parameters for our wastewater was pH. That was a pH of 3.5, so it was relatively acidic. Everything else was pretty low, like turbidity, which is the kind of the clarity of the water if you were to look at it. And so this was pretty clear. Coliforms, which is like the bacteria in the water, we only got 2 for the sample that we tested. So that was actually really low. Not a lot of life forms in there. And then copper, which was really high, which is what we were kind of expecting.
So in the second part of the lab, we were able to treat the wastewater. So our goal was to remove copper and phosphate from it. And this was done through treatment steps, precipitation, filtration, and ion exchange. And precipitation, the goal was to determine the best pH in order to remove the copper. So what we did was we divided 3 liters of wastewater into 6 vessels. We added different volumes of NaOH in each vessel, and then we fast mixed the vessels at 120 RPM, and then slow mixed them at 15 minutes in order for those copper particles to clump together. And basically, the clarity of the water and how much of it clumped together was how we determined optimal pH within the vessels.
So in Israel, they have standards for their industrial wastewater. They have to stabilize the pH of that water, lower the metal content, and this only has to be enough to meet the sewer standards, where then the municipal wastewater treatment plants take care of it. In Israel, they have a company called Elad Industrial Wastewater, and they remove heavy metals, cyanides, chromates, etc., and they use ion exchange, reverse osmosis, evaporation, and chemical treatment, and other treatments as well. In Israel, they cannot discharge sewage with a pH of 6 or lower, or a pH of 10 or higher, and they cannot into a sewage system, and they cannot discharge sewage with a pH that's less than 6 or higher than 9 into a reservoir.
So an application that we found for treating industrial wastewater in the Southwest was for a company called Anacoat Metal Finishing. They did processes very similar to Extol, but they used different coatings for their metal. Our goal was to discharge this treated wastewater into a local creek, which is only 4 miles north of the location, Los Penasquitos Creek. You can see the different coats that they put on the metal on the top right. And we found, just as an example, we found a way to remove electrolysis nickel through this study. What they did was they used a double chamber electrodisposition cell, and they also used water hyacinth leaves in order to remove the nickel from the wastewater. Once the wastewater was in this double chamber, the metal ions would be attracted towards the cathode surface in the chamber. And within 72 hours, all of the metal ions would have been attached to the cathode. So 99.98% of the nickel was removed. And this is these statistics are good because the limitation for the amount of nickel you could have in your water is only 3.98 milligrams per liter, and they had 0.4 milligrams per liter, which was meeting the standard.
Here you can see the double chamber that Alec was talking about. We got a cation exchanger and anion exchanger, and in the experiment they used H2SO4 sulfuric acid in order to have it for regeneration.
So here's just some pictures from our experiences in the labs at Israeli in Jerusalem. And you can see in the different pictures the different samples of wastewater that we had.
And just some reflection questions to think about. One, why is it so important to treat industrial wastewater? Another question is there any feedback that you can give on our water treatment train? And who do you think should be responsible for treating industrial wastewater?
So we just want to thank you guys for watching. I know we had a really good time learning about all this, and it was a really interesting experience to go to Israel and get to see kind of their process and then come back here and kind of figure out, okay, how can we apply this to an area in the Southwest, more specifically Southern California, because of our, struggles with water currently. So, yeah.
Thank you.
Thank you.